Welcome back to Inorganic Tutors Institute. In today's lecture, we are basically going to solve quiz 1 on algebra and trigonometry. Quiz 1, right? So the first problem is we want to find the other real zeros given that x plus 5 is a factor of this polynomial function, right? So our target is to find other real numbers, the other real roots, right? Now, if the results you have are not real roots, then there is no other real roots, right? Good. So this is a factor of this polynomial function. This means that if we set this expression to 0 and we substitute the result into this polynomial function, the result must give us 0 because it is a factor. But if you substitute x plus 5 equals 0 into this polynomial function and the result does not give 0, then it means that this x plus 5 is not a factor to this polynomial function, right? So let's try it out. X plus 5 equals 0. This implies that x is equal to negative 5, right? So we're going to substitute this into this polynomial function. F of x equals x cubed plus 2x squared plus 5x plus 10, right? So we substitute minus 5 in place of what? X. So you have 5 negative 5 cubed plus 2 into negative 5 squared plus 5 into negative 5 plus 10, right? So when you sum this argument very well, you're going to have minus 90, right? So this minus 90 means that this x plus 5 is not a factor to this polynomial function, right? So in here you can even conclude and say that there are no other real roots, or you can say that x plus the function was giving us f of x equals x cubed plus 2x squared plus 5x plus 10, right? Now we can decide to factorize this, right, and find the values of what? X. We try to find the zeros, right, to see if there are some roots that might be in the options, right? So we set this to 0, then we say that x cubed plus 2x squared plus 5x plus 10 equals 0. So you solve for this, you could realize that you can factorize this into 1, factorize these two terms into 1. So you have x squared out, you have x plus 2 plus 5 out, x plus what? 2 equals 0. So this is common, x plus 2 is common. So we add the outside argument, right? So we have x squared plus 5 and then x plus 2, right? So you set this to 0, set this to 0. So when you set this to 0, you're going to have s plus 2 equals 0. This implies that s is minus 2. So that is one real root. The next root is going to be x squared plus 5 equals 0. Then you have x squared equals negative 5, right? So we need x. So we have x to be equal to negative plus or minus 5i, because this is going to be square root of negative 5, and you know it is complex, right? So it's going to be plus or minus 5i, and this is not a real root. This is not a real root. Complex number is not a real value, right? So this is not considered. We only consider this real root, which is minus 2. But minus 2 is not part of the options given, right? So we say that no other real roots, no other real roots to this particular problem. No other real roots. Very, very simple. Very, very simple. Okay. So we move on to, okay, so with question number 2, with question number 2, it's very easy. It said we should simplify P intersection P prime intersection Q union P intersection Q, where P and Q are subsets of the universal set U, right? So this here, I can simply say that P prime intersection Q union P intersection Q is the same as this. will break this down and then you have Q, right? Now let's go through the steps, right? So we know that this thing, when you simplify, you get what? Q, and that is A. So let's use the distributive law and the complementary law to simplify it as well. That is the process. So the distributive law says that if you have A intersection B union A union C intersection B, then this is the same as A union C intersection B. B is common, so we factor B out, right? So this is what we have. This is the distributive law. So let's apply that here. So we have P prime intersection Q union P intersection Q, right? So this is the same as Q is common, right? So we try to factor out Q. So we have P prime union P intersection Q, right? So we factor out Q because Q is common, right? Q is common, so we factor out Q, and then we have this in there. Now, remember, this here, according to the complementary law, we know that this will give us U, right? P prime union P will give us U, and so this will give us this, right? Union intersection Q. So, and you know that this will result to what? Q. Right? This will result to what? Q. So this is the distributive and the complementary law. So it's either you go through this and then get this, because this is just complement and this is not a complement. So this cancels this, and then you only have Q union Q, and Q union Q is the same as Q, right? But if you go through the process as well, using the distributive law and the complementary law, you get back to the same result, right? So when you simplify P prime intersection Q union P intersection Q, you get Q, right? So that is question number 2. Let's move on to question number 3 and 4. With question number 3, we have to solve the absolute value inequality, right? The absolute value inequality is given as x plus 3, absolute value of x plus 3 greater than 4, right? So this, you know that absolute value contains plus and minus, right? So you have plus and minus of x plus 3 greater than 4, right? So if you take the positive side, you're going to have x plus 3 greater than 4, right? So if you solve this, you have x greater than 4 minus 3. So you have x greater than 1. That is the first part. Or negative into x plus 3 greater than 4. So you have negative x minus 3 greater than 4, right? So you have minus x greater than 4 plus 3. So you have minus x greater than 7. We need x, not negative x. And you know that if you divide by a negative value, an inequality, right? So you're going to have the sign changes to less than negative 7, right? So you have the answers for the absolute value is x greater than 1 or x less than negative 7, right? So the right option is A, s less than negative 7 or s greater than 1. That is this question 3. Now with question 4, we are to solve this absolute value problem, right? So this we have absolute value on both sides of the inequality, right? So we have to square both sides, right? So if you square both sides, you're going to have absolute value of 3x minus 1 all squared greater than or equal to absolute value of 2x plus 3 all squared, right? So if you do that, the negative will go away, right? So we're going to have 9x squared minus 6x plus 1 greater than or equal to 4x squared plus 2 times 2 is 4, 4 times 3 is 12. So we have 12x plus 9, right? So remember, if you have absolute value on both sides of the inequality, you square both sides to eliminate the absolute value, right? So this, if you bring this ones here, you're going to have 9x squared minus 4x squared minus 6x minus 12x greater than, right, plus 1 minus 9 greater than or equal to 0, right? So if you solve this very well, you're going to have this, you are going to factorize it, and you have 5x plus 2, and then we have x minus 4, and that is equal to what? 0. So if you solve this, you are going to have, right? So you're going to have 5x plus 2 greater than or equal to 0. So it means that x will be greater than or equal to minus 2 over 5, right? Or we have x minus 4 greater than or equal to 0. So if you solve this, you are going to have s greater than or equal to 4, right? So we have 5, or s is greater than or equal to 4. So that is option A for this particular problem. Option A for this particular problem, right? So that is question number 4. Now let's move on to question number 5. And with question number 5, we are asked to check which of the following fractions is an irrational number, right? So remember, 101 divided by 15, 5 over 16, 2 over square root of 5, and D, 4 over 32. Which one is an irrational number, right? So for you to identify the irrational numbers, if you see square root of a square, right, a set, right, a set, and the argument inside the set cannot be or it's not a perfect number, then that particular set function is an irrational number. So for instance, square root of 5, square root of 7, upwards, they are irrational numbers. So if you see set, it's an irrational number. If you see pi, it's an irrational number, right? If you see e, it's an irrational number. So these are the irrational terms, right? Set, pi, e, they are all irrational numbers, right? So we have 101 over 15. This is not an irrational number. This is a rational number. B. We have 5 over 16. This is a rational number. C. We have 2 over square root of 5. This is an irrational number because set is at the denominator, right? We have square root of 5 over there. So square root of 5 is an irrational number, right? It's an irrational number. So option C is an irrational number. So which of the following fractions an irrational number is option C, 2 over square root of 5. 4 over 32 is not an irrational number, it's a rational number. Right, now question 6. A fraction or a function is given by absolute value of x plus 5. What is the range of this function? Good. This is a very good example that we have to look at, or this is a very good question that we have to look at. Now, recall the absolute value property, right? The absolute value property. remember that absolute value of x must be greater than or equal to 0, right? If absolute value of x, that is a property, absolute value of x must be greater than or equal to 0. So absolute value of x must be greater than or equal to 0. So if that is the case, then let's add, because there is 5 here, let's add 5 to both sides, right? So if you add 5 to both sides, you are going to have absolute value of x plus 5 greater than or equal to 0 plus what? 5. So it means that you are going to have this here, and then you are going to have this here. So it means that if you solve for this, you are going to have absolute value of x greater than or equal to what? 0. So recall, when you have a problem of this nature, recall the absolute value property, right? The absolute value property. So absolute value of x must be greater than or equal to what? 0. Must be greater than or equal to 0. So you could see that the function f of x is greater than or equal to what? 5, because the smallest value of the function x, the function f of x, is 5, because we added 5 to both sides, right? The smallest value of the function f is 5, right? So the range here is going to be y greater than or equal to 5, right? So the range is y such that y is greater than or equal to what? 5. So if you have a problem of this nature, just recall the properties, right? So the absolute property says that if you have absolute value of x, then it must be greater than or equal to 0. It must be greater than or equal to 0, right? So that is the solution to this. The absolute value of x plus 5, the range of absolute value of x plus 5 is y is such that y is greater than or equal to 5. So option B. Right. So that is the solution to question number 6. Let's look at question number 7, right? So with question number 7, we ask to which of the following is not a subset of Q, right? So with this problem, it's very simple. They are just properties. They are properties that you have to follow systematically, and then you are good to go. So remember, natural number is a subset of what? Whole numbers. Natural number is a subset of what? Whole numbers. And integers is a subset of what? Whole numbers, right? Natural numbers are a subset of whole numbers. Integers are a subset of whole numbers, and rational numbers are a subset of what? Integers. And rational numbers are also a subset of what? Real numbers. And real numbers are a subset of what? Complex numbers. So that is how the mapping goes. So we have first one, natural numbers being a subset of whole numbers, and whole numbers are a subset of what? Integers, right? And integers are a subset of rational numbers, right? So you have rational numbers, and rational numbers are a subset of what? Real numbers, right? So we have real numbers here. Then real numbers are a subset of what? Complex numbers, right? So which of the following is not a subset of what? Q. So Q, yes. So Q is rational numbers, right? And rational numbers, all these ones are a subset of what? Rational numbers. But rational numbers cannot contain real numbers, right? But real numbers can contain rational numbers, right? So real numbers cannot be a subset of what? Rational numbers. So the answer here is real numbers, right? The answer here is real numbers. So you have to understand the concept. It's very simple. So this is the mapping. right? So if you see it in other way round, this is the mapping. Natural numbers are a subset of what? Whole numbers. And whole numbers are a subset of what? Integers. And integers are a subset of what? Rational numbers. And rational numbers are a subset of what? Real numbers. And real numbers are a subset of what? Complex numbers. Okay? Now, what are natural numbers? You know, natural numbers start from 1 to infinity. And whole numbers start from 0, right? So you can find natural numbers in whole numbers, but you cannot find all whole numbers in natural numbers. So natural number is a subset of what? Whole numbers. Again, you can find whole numbers in natural numbers, but you cannot find integers in whole numbers. Remember, integers are positive and negative whole numbers, right? Positive and negative whole numbers. But then whole numbers can be obtained in this, but not this in that. Remember, these are whole numbers. -1 from this section up to 0, 1 to infinity. These are natural numbers, integers, right? These are integers. And this is what? Whole numbers start from 0, 1 to infinity. And natural numbers start from 1 to infinity. But rational numbers, they are fractions, right? So if you have this p over q, this is a rational number, right? And rational number, you can obtain it what? In integers, but you cannot obtain integers. You cannot obtain rational numbers in integers, right? You cannot obtain rational numbers in integers. So the best, that is the mapping for this real numbers. Natural numbers, from ascending order, we have natural numbers, whole numbers, integers, rational numbers, real numbers, and complex numbers, right? So you cannot obtain real numbers in rational numbers. So the only one that is not a subset of rational numbers is what? Real numbers in here. Real numbers. Okay, question number 8. We want to find the domain of this function, right? G of x is equal to square root of 4 minus what? X squared. Remember, if you have an argument under the square root sign only, right, and you want to find the domain, then you have to equate the argument under the square root sign to greater than or equal to what? 0. So we have 4 minus x squared greater than or equal to what? 0. So it means that negative x squared is greater than or equal to minus 4. So if you solve for x, you're going to have x less than or equal to plus or minus 2, right? So it means that the domain of this particular function is -2 less than or equal to x less than or equal to 2. So that is the domain of this particular function. Just have to equate the argument under the square root sign to greater than or equal to 0, right? So always the argument here must be greater than or equal to 0. If it is a fraction, if it is not a fraction, right? If it is not a fraction and you want to find a domain, this is how you do it. If the argument is under a square root only, then you equate the argument under the square root sign to greater than or equal to what? 0. And then the result is what you have here. So the answer is -2 less than or equal to x less than or equal to +2. So that is the domain of this particular function. That is very simple, right? Now, with question number 9, it says that all the following are rational numbers except, so we have 5.1333. So it means that this keeps occurring, right? So this is a rational number. And then we have 7 pi. Remember from question Yes, from question 5, I said that if you see pi is not a rational number because pi is 3.1142. The subsequent values are not consistent, right? The subsequent values are not consistent. So it means that pi is not a rational number. Pi is an irrational number. So straightforward, we rule out 7 pi. So it means that 7 pi is not a rational number. 7 pi is not a rational number. We have square root of 25. Square root of 25 is a rational number because you can break square root of 25 down. You have square root of 25, which is equal to what? 5. And 5 is a rational number. And then 25 over 7, if you break it down, you have a simple decimal, which is what? A rational number. So the only irrational number in here is 7 pi. 7 pi. So that is the only exception in here. That is question number 9. With question number 10, given any two real numbers a and b, one of the following statement is true, right? A greater than b, a less than b, or a is equal to b. This statement is known as trichotomy law. This statement is known as trichotomy law. We have the zero product law where you have 0 times an argument, and this is equal to what? 0. We have the cancellation law. The cancellation law is also there where you have AC is equal to BC, right? So you multiply here by 1 on C, you multiply here by 1 on C, and this cancels this, and this also cancels this, and say you have A is equal to what? B. This is the cancellation law, and this is the zero product, zero multiplicative law. And then the zero product theorem is A dot 0, right? So this is also what? 0. So this is what? The laws. So this particular law is what? Trichotomy law. A trichotomy law. So note this very well. Now, the question 11 says that which of the following holds for the set of all real numbers, right? So for all real numbers, addition property holds for all real numbers because it works for the inverse, it works for the associativity, it works for the identity, it works for the commutativity. The equality law also works, and the transitive property also works. The transitive property also works. So basically, this works, this works, this works, and this is the only exceptional one. This is not a standard property for real numbers, right? So the translative property is not a property for real numbers. So the only odd one out here is the translative property. The translative property. So if you don't see this, then the rest all are what? Properties for real numbers. Addition, equality, transitive, transitive, and then yes, these 3. They are all properties of what? Real numbers, except the translative property. Now, with question number 12, we want to find the quadratic equation whose roots are 1 minus square root of 5 and 1 plus square root of what? 5. We want to know the quadratic equation. So we know the standard formula, right? X squared minus x plus x1 plus x2 multiplied by x plus x1 times x2 equals 0, right? So you find the summation of the roots, you find the product of the roots, then you substitute into the formula, right? That is very, very simple, okay? That is very, very simple. So you just have to do this, then you substitute in, then you find the equation, the quadratic equation. So let's find the summation first. So if you sum these two, plus 1 plus square root of 5, this cancels this, and so we have 2 here, right? So the summation is 2. Now let's find the product. x1 times x2 will be 1 minus square root of 5 multiplied by 1 plus square root of what? 5. So this will give us 1 plus square root of 5. This will give us minus square root of 5. Then this will give us minus 5. Right, so this will take up this, and then we have this will give us minus 4. So we substitute those terms into the general or the standard formula. Then we have x squared minus into brackets. This will give us 2 here times x plus minus 4 equals what? 0. So we have x squared minus 2x minus 4 equals 0. So this is the quadratic formula whose equation, whose roots are 1 minus square root of 5 and 1 plus square root of 5. The quadratic formula or the quadratic equation is x squared minus 2x minus 4 equals 0. That is it for question 12. So with question number 13, we want to find the vectors of the parabola, right? And the parabola is 17 plus 6x minus 3x squared, right? So the parabola given, we want to know the vectors of this particular parabola. So what we do is that we find the axis of symmetry, and then we find the turning points. This together becomes the vectors of the parabola, right? So first of all, the axis of symmetry will be equal to negative b over 2a. Remember, the general quadratic formula is x squared plus bx plus c equals 0. So we compare this with this, we are going to have a to be equal to minus 3, b is equal to 6, and c is equal to 17. So the axis of symmetry will be minus b, which is 6. So we're going to 6 over 2 into what? Minus 3. So we have minus 6 over what? Minus 6, which is what? Positive 1. So the axis of symmetry is positive 1, which is the x value. Now, to get the turning point, you can either use the formula or you substitute the x value into this equation, then you find the axis of the turning point, right? So substitute this into this instead. You're going to have y of 1 is equal to 17 plus 6 into 1 minus 3 into 1 squared, right? So we have 17 plus 6 minus 3, right? 17 plus 6 minus 3 is 20, right? So the vectors of this parabola is 1 and 20. 1 and 20. So if you want to find the vectors of a particular parabola, first find the axis of symmetry, which is the x value, which is, you can easily use the formula minus b over 2a. So if you get the axis of symmetry, which is the x value, substitute the x value into the parabola given, then you find the y value. These 2 points becomes what? The vectors of the parabola. So in here we have 1, 20, 1, 20. So with question number 14, we have to determine the axis of symmetry for this parabola, right? So it's very easy because we have done similar work from question 13, right? So we're going to have this compared to the general quadratic formula plus c equals 0. So we have a is equal to minus 18, b is equal to 12, and c is equal to minus 25. So as usual, the axis of symmetry formula is x equals minus b over 2a. And b here is 12. So we have 12 divided by minus into bracket 2 into bracket what? The a is minus 18. So we have minus 18 here. So we're going to have 12 over what? 36, right? And this is going to give us 1 over 3. So the axis of symmetry of this particular parabola is 1 over 3. So that is question number 14, 1 over 3. Very, very easy. Very, very easy. So that is the question number 4. So with question number 15, we want to find the Cartesian product of P cross T, right? If P is equal to 3, 5, 7, and T is equal to 3 and 5, right? These are the set given, and we want to find the cross product of P and T, right? So we have P cross T is equal to 3, 5, 7 cross 3 and 5, right? So as usual, the first element in the first set moves with the first element in the second set. The first element in the first set moves with the second element in the first set. Then that completes the first element in the first set. The same thing applies to this. Matches it with the second element, matches with that until all are exhausted, right? So we're going to have the element to be 3, 3, 3, 5. Then we have 5, 3. We have 5, 5. We have 7, 3 and 7, 5, right? So these are the elements that can be obtained from finding the cross product between P and T. 1, 2, 3, 4, 5, 6, right? And you know that we have 3 elements here, 2 elements here. So 3 times 2 is 6, right? So that is it for this particular problem. Very, very simple. Now, with question number 16, we want to solve for T in this particular equation, right? So we have 0.1 minus into bracket T squared plus T equals 0.01, right? So what we have to do is to, expand this bracket, move this to the left hand side, equal to 0, right? So we have 0.1 minus T squared minus T equals 0.01, right? We bring this here and then we set it to 0, right? So we have 0.1 minus 0.01 minus T squared minus T equals 0, right? So we have T squared minus T T plus 0.1 minus 0.01 becomes plus 0.09, and then we equate it to 0, right? So you can decide to divide through by -1 so that we avoid a negative in front of the squared, right? So we have T squared plus T minus 0.09 equals 0. So we solve this quadratically. We realize that this expression, we cannot factorize it, right? Unless we use the quadratic formula, right? So if you use the quadratic formula, we are going to have the first value for T to be equal to -5 minus square root of 34 divided by 10, or T is equal to -5 plus square root of 34 divided by 10. So that is the values of T. These are the values of T. T is equal to -5 negative square root of 34 divided by 10, or T is equal to -5 plus square root of 34 divided by 10. So these are the two values of our T. You used the quadratic formula to solve this, right? Remember, minus b plus or minus square root of b squared minus 4ac divided by 2a, right? So you identify your a, b, and c, and you know that your a from here is going to be 1, b from here is going to be -1, and b from here is going to be +1, and c is going to be -0.09, right? So substitute into this, and the result for T is going to be this. So this is question number 16. Let's move on with question number 17. We have to solve for x if the absolute value of 4 minus x is less than -3. Note, if you have an absolute value, it can never be less than 0, and it can never be anything, it can never be less than 0, right? So an absolute value, remember the absolute value property. An absolute value of a function can never be less than 0. It can be equal to 0 or greater than 0. So this is the condition, or this is the property for an absolute values, right? This is the condition for absolute values. So realize that if you compare this to this, you can see that 0 is never less than -3, right? So already this condition or this problem is ruled out, right? So this, anytime you see an absolute value that is less than 0, or yes, that is negative in here and it is less than, then it means that that particular absolute value function is empty, right? So if you have an absolute into bracket an expression here, all right, and it is less than a negative number, then it will be an empty set, right? It will be an empty set. It will be an empty set. So basically this problem, it is an empty set. The solution is an empty set. Remember, if you fix this here, if you fix this, right, you're going to have 4 minus x less than -3, right? So it means that you're going to have -x less than -7. So x is greater than 7. Or you have -4 plus x less than -3. So x is less than 1, right? Right. Substitute 1 here. You're going to have 4 minus 1, which is 3. Absolute of 3 is 3, right? And 3 is never less than -3, right? If you substitute 1 here, you're going to have what? 3. 3 is never less than -3. So already this condition does not hold. This problem is indirectly an empty set. Once you see an expression inside an absolute value and an expression inside an absolute value and it's less than a negative number, already it is an empty set. It is an empty set because you can never have an absolute value less than 0. It can be equal to 0 or greater than 0, right? It can be equal to 0 or greater than 0. Remember, an absolute value does not tolerate a negative value, right? So if you have an absolute value of -3, that means that it is going to be what? +3, right? So that is it for this particular problem. The answer is an empty set, right? So that is it for question number 17. With question number 18, we are asked that which of the following are x-intercepts for the graph of the function h of x is equal to this polynomial function 6x4 minus 7x cubed minus 37x squared plus 8x plus 12, and the options are this, right? So we have to solve for this to be able to get the s-intercept of this particular polynomial function, right? Now, this polynomial function, to get the x-intercept, it means that y is equal to what? 0. At the x-intercept, y is equal to 0, right? So we are going to have 6x to the power 4 minus 7x cubed minus 37x squared plus 8x plus 12 equals 0, right? So we have to solve for this and find the values of what? X. But we can't easily solve this like that. We have to use the rational root theorem. We have to use the rational root theorem, right? Remember, the rational root theorem states that you find the coefficient, the factors of the constants over the factors of what? The the coefficient over here, right? Factors of the constant over the factors of the coefficient of the highest power, right? So in here we are going to have what? 12 over what? 6. So we have to find the factors of 12 and then factors of what? 6. Then we find the we find the what? We divide this by that, divide that by that, like that. Then we get the possible terms, the possible divisions, right? Then we will be able to get the possible rational root that will be obtained from these factors, right? So you know that the factors of 12 will be equal to plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, right? And the factors of 6, 2 is plus or minus 1, plus or minus 2, plus or minus 3, right? So we take the constant, the factors of the constant, which is the factors of 12, over the factors of what? 6. So we do it one after the other. So we take it, we are going to have plus or minus 1, comma, plus or minus 2, comma, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 1 over 2, plus or minus 1 over 3, plus or minus 3 over 2, plus or minus 2, yes, plus or minus 4 on 2, 4 on 3, and then plus or minus 2, right? So we take it after finding the factors for the coefficient of the highest power and the constant, then you divide the constant by the coefficient of the highest power. So these are the possible roots. These are the possible roots that we can get from this, right? That we can get for this. Now, all these roots cannot satisfy this. There are some of them that will satisfy this. If you substitute into this, it will give you 0. So we say that s plus 2 should be equal to 0. So this implies that s is equal to minus 2. When you substitute minus 2 into this expression, you are going to have 6 into minus 2 into power 4, minus 7 into minus 2 power 3, minus 37 into minus 2 power 2, plus 8 into minus 2 plus 12 equals 0. So if you sum all this, you get 0, right? So this means that s plus 2 is a factor, right? So we use this s plus 2 and then the polynomial function to find the other factors, right? So we are going to say that s plus 2 equals 0 is a factor. So we take that s plus 2, we put this inside 6x4 minus 7x cubed minus 37x squared plus 8x plus 12, right? If you factor this very well, you're going to have 6x cubed minus 19x plus 19x squared plus x plus 6, right? If you factor this very well using the polynomial division, you're going to have 6x cubed minus 19x squared plus x plus 6, right? So that is the other factor, right? So you have s plus 2, then we have 6x cubed minus 19x squared plus x plus 6, right? Now, we have to break this down again, right? We have to break this down again. So we are going to use another factor, right? We are going to factor this cubic root again, right? We are going to factor the cubic root again. So we have to choose another real root, right? That will be able to make this thing 0, right? So we consider to factor the cubic root as well, right? So let's test let's test s equals 3, right? So that means that s minus 3 will be the factor, right? So we put that here, then we use the polynomial division, minus 19x squared plus x plus 6, right? So we break this down, and then we are going to have 6x squared, right? 6x squared minus x minus 2, right? So this will be the polynomial division, right? So we're going to add x plus 2, x minus 3, and then 6x squared minus x minus 2 equals 0, right? So we have to factor the quadratic expression as well. When you factor this quadratic expression, minus x minus 2, this is the same as 3x plus 2, right? 3x plus 2, and then 2x plus 1, right? If you factor this, you are going to have 3x plus 2 and 2x plus 1, right? That is what you are going to have if you factor that out, right? So yes, 3x minus 2, right? So this means that all the factors are going to be x plus 2, x minus 3, 3x minus 2, 2x plus 1 equals 0. So these are the factors of this polynomial function, right? So we're going to have x plus 2, x minus 3, 3x minus 2, 2x plus 1 equals 0. So we have x plus 2 equals 0, x is equal to negative 2, 1 factor, x minus 3 is equal to 0, s equals to 3, 1 factor, 3x minus 2 equals 0, s equal to 2 on 3, 1 factor, and then 2x plus 1 is equal to 0, s is equal to minus half, right? So we have the fourth factor. Now, the question says that at the x-intercept, right? So it means that y is 0. So if y is 0, then it means we are going to have minus 2, 0, or we are going to have 3, 0, or we are going to have minus half 0, or we are going to have 2 on 3, 0, right? So these are the points: minus 2, 0, 3, 0, minus half, 0, and 2 on 3, 0, right? So these are the points. These are the 4 points for solving this polynomial function, right? So if you have a polynomial function that has a degree more than 3 or even 3, and you are not finding or you are not getting the real or the zeros easily, use the rational theorem, right? Points, right? Or 0 that will make this function go to 0, or that will make that particular polynomial function go to 0. Then what you have to do is to straightforward go to the rational root theorem. You have to use the rational root theorem to make your work very easy. So with the rational root theorem, what you have to do first is to find the factors of the coefficient of the highest power, right? So we find the factors of the coefficient of the highest power, and of course in here the coefficient of the highest power is what? 6. So we find the factors, which is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 itself, right? So if you are taking the factors, take both positive and negative, right? Because you don't know which one we're going to give the function to be what? 0. Then you find the factors of the constant, right? So you find the factors of 12, plus or minus 12, plus or minus 6, plus or minus 4, plus or minus 3, and plus or minus 2, and plus or minus 1, So these are the factors. So after getting the factors of these two numbers, you find this, you take this here, the P divided by Q. So the P is this and the Q is this, right? Then use these numbers, the division that you have. So the P is the factors of what? 12, and the Q is the factors of what? 6. So you divide each factor of 12 by the factors of what? 6, right? So the result that you have, use those results to test to see if the polynomial function will go to what? 0. Then those points are the factors of the polynomial function. Then use it to derive the other remaining factors, right? If you get one factor, you can use it to get the other remaining factors. So that is the end of this lecture. Thank you very much for watching. I really appreciate your time. Please don't forget to subscribe, share with your mates, and I'm going to give you more updates. Bye bye.